All right, let's do part B now. It says find the average velocity of the particle for the time period from t0 is less than or equal to t is less than or equal to 6. So let's just remind ourselves, our average velocity is going to be our change in position divided by our change in time. Now, what is going to be our change in position? Well, our change in position, they didn't give us the position function, but we can figure out the change in position by taking the integral of the velocity function. So we're going to take the integral over that time period from t equals 0 to t equals 6, 0 to 6, of v of t dt. And then what is our change in time? Well, our change in time is 6. And so we're going to divide it by 6. And so what is this going to be equal to? Well, this would be the integral from 0 to 6 of v of t is 2 sine of e to the t over 4th power plus 1 dt. And then we're going to divide that whole thing by 6. Now, lucky for us, we're allowed to use a calculator on this portion of the AP exam. And so let's do that. So to evaluate a definite integral, I would hit math here. And then we see it's number 9, so I hit 9. And then we just fill in the parts of the integral. And so let me move this to the left a little bit. And so we are going from t equals 0 to 6. And then I'm going to integrate 2 times sine of e. So let me take, so I'm going to go e to the, and then t over 4 power. So let me do that. And I'll just do x over 4. I'll integrate with respect to x here just because that's an easier variable to use on this calculator. So there you go. I have 2 sine of e to the x over 4. And so let me now close the sign here. And then I have plus 1. And then there you have it. And then I am integrating with respect to x. And so I click enter. I am going to get that. And then I can divide by 6. Divide by 6. And I get roughly 1.95. So this is approximately 1.95. So now let's do part C. Find the total distance traveled by the particle from time t equals 0 to t equals 6. So you might be tempted to say, hey, you know what? I'm just going to take the integral from t equals 0 to t equals 6 of my velocity function, just like that. And you would be close, but that might not give you the right answer. To appreciate the difference between what we have here, this would give us our change in position like we just saw, or our displacement. And to appreciate the difference between that and distance, imagine a particle that at time equals 0 is here, and that from time equals 0 to time equals 6, it goes all the way to there, and then it goes back over here. Your change in position would just be that amount, while your total distance traveled would be this plus this. And so what you want to do is take the absolute value of this. So even when you go backwards, when you have a negative change in position, it adds to your total distance traveled. And so to be clear, this is going to be equal to the integral from 0 to 6 of the absolute value of 2 sine of e to the t over 4 power plus 1 dt, which is equal to. So to do that, there's a couple of ways to do it. I could either modify what I had before, or I can just hit math, and then number 9 is the definite integral again. And I'm going from 0 to 6 of, and now I want to take the absolute value of all of that. So I could do math, and then number, and then absolute value is the first choice. Enter absolute value of 2 sine of e, second e, to the x over 4, x divided by 4 power, and then I want to close the parentheses on the sign, and then I have plus 1. And I click, and I have to say, and I'm integrating with respect to x, and then I click enter. And so notice, our total distance is different than our displacement over that time period. This object must have changed directions. And so this is going to be approximately 12.57. Now, last but not least, let's tackle part D. I'll do it right over here. For 0 is less than or equal to t is less than or equal to 6, the particle changes direction exactly once. Find the position of the particle at that time. Well, there's a couple of ways to think about it, but maybe the easiest is the particle is going to change direction when the velocity is going from positive to negative or from negative to positive. And so that would be a time when the velocity is equal to 0. And they say it happens exactly once. So what we could do is just say, when does our velocity function equal 0 in that interval? So we need to solve 2 sine of e to the t over 4 plus 1 is equal to 0. And actually, you can solve this using traditional methods, but you're going to have to use a calculator at some point to take a natural log. So let's just use the calculator solver function because we can. So we go to math, and then if we scroll up, we go to the bottom, which is numeric solver. Click enter, and our equation, the left-hand side, is 2 times sine of e to the, let's say, I'll just use x as my variable that I'm going to solve for, x divided by 4 power, and then close the parentheses on the sign, and then we have plus 1. And then the other side of the equation is equals 0. And I go down. And now I just have to give a guess. Maybe I'll go right in between of our interval from 0 to 6. And then I would hit solve. So alpha solve. And we get x is equal to approximately equal to 5.20. And of course, we were actually trying to solve for t. I just used x for the calculator. It is t is approximately equal to 5.20, which is indeed in that interval. Now, they didn't ask for the time when the particle changes position. They want to find the position of the particle at that time. What we can then do is input this time into what you could view as our change in position function to figure out how much the particle has moved, and they tell us where it started. So the position at this time is going to be equal to, our initial position plus our change in position, which is going to be the integral from time equals 0 to time is approximately 5.20 of v of t dt. And once again, we can use our calculator for that. And so we could say math number 9 here, definite integral. We're going to go from 0 to 5.20, and then we're taking the integral of 2 sine of, I've done it so many times now, I think I have it memorized, second e to the, and I'm going to just use x over here, x divided by 4 power, close the sign parentheses, plus 1, and then I'm integrating with respect to x. This is going to give us our change in position from time 0 to time approximately 5.20. And so that's going to be that. And we know what our initial position is. Our initial position is at 2. They tell us x of 0 is equal to 2. So plus 2 is going to be equal to 14.13, or approximately equal to 14.13. And we are done.